Hi, my name is Oscar Franco. I'm a freelance software engineer. I'm currently looking for a project if you're interested, but I want to talk today about runtime crash when invalidating native modules. This was reported last week to me, and it took a little bit of digging to find out what's happening. So let me give you a little bit of context why this was happening. So the crash was coming from destroying a JSI value on an async thread. This was from OP-SQLite. If you don't know it, it's a SQLite library for React Native that uses native C++ JSI bindings to do SQLite queries. It does it by creating a thread pool, and that thread pool executes your code on an off thread, so you don't block the main JavaScript thread of your application. Now, the problem was this was crashing. It was only happening when you were reloading, doing a hot reload in your local environment, or doing a over-the-air update. It could be code push, maybe expo updates, I'm not 100% sure. Now, let's take a look at the architecture that was working before. You would have, whenever you did a reload or restart your JavaScript bundle, it would call invalidate on your native modules. And there you have a window to do some cleanup, right? Like if you had open resources, if you try to deallocate memory, if you have a running process, you would try to interrupt that work. So it could be properly cleaned up by the run React Native code. And then it would restart your modules, right? And there you could again reallocate all of the values that you need, any shared pointer that you had, and then you continue executing your application. Now, with this architecture having a global state, it's safe because there's no overlap. Right? Like if I had a shared pointer here and I didn't clean it up, it didn't really matter because the instance would be completely killed and then a new one would be restarted. But I don't know if this was an intentional change or it was just an architectural change. Now that we have bridgeless mode, the React Native runtime and the code, it doesn't really wait for the resources to be completely cleaned up before starting the initialization of the modules. So now a new RCT instance starts before the old one finishes invalidating. And the old one gets a few seconds. It depends on the implementation. I think on iOS there is a hard time limit. On Android, I don't think there is. It seems a little bit more variable. But you basically have now a window where two generations of the JavaScript runtime overlap. So you can see here we have the old engine, you have the new one. And whenever you do a hot reload, the new one won't immediately start creating the new instances of the native modules, while the old one would get the invalidate call. And then they would be swapped, and the new one would already start accepting work, so you already see things on the screen, for example, while the old one was still valid and invalidating itself, right? So this is, you can imagine with its bridgeless architecture, maybe a performance gain with this. You don't have to wait for things to be fully invalidated. You can just swap whatever is running on the runtime. But it does bring a problem, right? The process, the global state is now shared by two runtimes at once. Let me explain a little bit with the code of OP-SQLite. In OP-SQLite code, we had shared pointers to the database object. So whenever you would open a database, we would append a shared pointer to that object. And we also had, for example, invalidated flag that would be used to kind of hold any oncoming work once your module has been invalidated. And we would also have, for example, a shared pointer to an invoker. This allows us to query async work back from the off thread into the JavaScript thread. And these were global variables, right? So now, let's say we have a database and it invokes some work off thread. right? And it's processing that work. Now, this invoker was global, and by the time it runs, install might have overwritten it. Like the new module might have already replaced that instance. So you're no longer talking to your old JavaScript runtime, but you're rather talking to the new one, right? So you don't have any reference anymore to the objects of those old objects that you had in memory, right? So the callback lands in the new runtime, and it touches a JSA value from the old one, from the dead one. So then we have like some threaded code, right? Like it tries to read, okay, I've been already invalidated, my invoker is there. There's some code that tries to avoid any null pointer execution, but it doesn't really work, right? Like you will still crash because you're referencing stuff from a previous generation. You will try to destroy objects, maybe not already on the JavaScript thread, but on the off thread. It just brings a whole lot of problems. So how do we solve this? So one way to solve this is using a flag per generation, right? So whenever the module starts, we will create generation alive, which is a shared pointer. It has to be atomic because it will be accessed from different threads. It's basically a Boolean, right? So whenever our module is installed or created, we create a new atomic Boolean. And then when the runtime is tearing itself down, we will share that pointer to false. So now we take that pointer and we copy that every time we create a new database object, right? So each database object will kind of be tied to that specific shared pointer for that generation. So you can see we have the shared pointers, and let's say on the database object, we're doing an update. So then we check, is this generation still alive? Yes, no. If it's still alive, then we can safely invoke our callback from our C++ code into the JavaScript code, right? The same trick for whenever we have a work off thread on a pool. Since we have the shared pointer that's living, that is shared inside of the database object, then whenever we get a callback, we will do the same, right? Like even if we're off thread, we still need to check if the work that we include on the original JavaScript runtime, if that's still valid, we can still safely call it. So again, this is also something that might be useful if you were doing off-thread work. You get a budget now while the engine is tearing itself down, right? If you go over that budget and you haven't cleaned up your module, you will leak objects maybe. You will get concurrency errors because you will try to join stuff back into the dead JavaScript thread. So for example, on SQLite, it is very important. Once the JavaScript runtime has invalidated your module, we have to cancel any ongoing work, right? Like you might have a query that's taking, I don't know, 10 seconds, 20 seconds to run. That's going to go over the budget. So we have to interrupt it as soon as we can. And once that's interrupted, we have to properly clean our resources, right? So we call SQLite3_interrupt. So we can cancel any off-thread work. And then you already saw the code. Our async task is going to complete. It's going to check for generation alive flag. It's going to do nothing because it cannot do anything anymore. And then we can close our thread pools. You can also do mutexes if you have global state, right? So let's say we have on our database vector that I showed you at the beginning, whenever we get the invalidate call, we get a hold, we get the lock on the mutex, and we clean everything. And then only after we have cleaned it, then we can release it, and the new module will be able to safely start queuing up objects. So there's a little bit of a trade-off there, right? Like you have a mutex, and now you have to kind of worry about the race conditions inside of your module. So one way to do it is to lock the state and properly clean it. The other way is to re-architect your module in a way that it doesn't require mutexes or concurrency on these structures, right? So passing the alive flag allows me to encapsulate, make every database object its own thing. It has the shared pointer to the generation, and that kind of solves most of the issues. Right, so the takeaways. Bridgeless now means you might have two engines alive at once, even if it is for a few seconds. You can no longer trust a global value, right? So let's say for now the current runtime from a callback, that might be replaced. You might have to capture identity at creation time, and invalidate means this instance of your module is dying, not the module itself. In shared state, you will need to now worry about real locks, mutexes whenever two generations can coexist. Yeah, you need to take care of cleaning up the resources properly whenever you get the invalidate call. Well, that's it, guys. I hope you learned something today. This is very interesting work. Remember, if you need some React Native expert, I'm available, so take care.